Okay, last time we were solving one numerical. I told you one of the methods how it can be solved. So same numerical we can solve by another method by modifying the formula. We have to use a shortcut wherever possible which is allowed by the board. So same numerical I am solving by other method. What was given that I am writing again? Refractive index of glass with respect to air or absolute refractive index. Refractive index of water was given as 4/3. You were asked to find out refractive index of glass with respect to water and refractive index of water with respect to glass. So how this can be done? By using this, you were given additional data. Speed of light in air is 3 into 10 raised to 8 meter per second. Observe the data. Actually, to find out these values, this is not needed. This is the additional information that is given, but for few students who only use the basic principle, those who don't want to use the modified methods, for them this is required. For those who don't want to use basic method, they can use short form. The formula is to be generated. See how you can write ANG, refractive index of glass with respect to air, VA upon VG. This is my equation number 1. How I can find refractive index of water with respect to air, VA upon VW. This is my equation number 2. Now I want to find out, so let us say W and G I want to find out. W and G, what is the formula for this? VW upon VG. How can I modify this formula in terms of this? Let us check. I will write 3/2 here for 1.5 for easier calculations. Now VW upon VG, I am writing here VA upon VA into VW upon VG. Check whether there is any change made in the formula. I don't think so, because this is as good as by multiplying by 1, you can cancel out. Now it's the question of rearranging the terms. I am writing this as VA upon VG upon VW upon VA. VA upon VG everyone can understand, and multiplied by it will be VW upon VA. What is this VA upon VG? It is ANG into, again modify this. Now you can remember the final formula. In the exam you don't have to carry out all this procedure. This is for your understanding how the formula is generated. I can write this factor as 1 upon VA upon VW. Check. Forget about this. This is the basic definition. VA upon VG is ANG multiplied by as it is. Now I am taking VW in the denominator. This is same as this. This VW is going to go up and value is retained. What is VA upon VW? This is ANG as it is multiplied by 1 upon A and W, that is A and G upon A and W. This is what? W and G. Do I have the value of A and G and A and W? Those are the values given. Just substitute those values. So A and G is 3 by 2 and this is 4 by 3. That is equal to 3 by 2 into 3 by 4, that is 9 by 8. That will be 1.125. Now check the answer which you have got by the basic method. We have solved this by some different method where we got the same answer 1.125. Another easier method, G and W is what? 1 upon W and G. This we have already done. 1 and 2 equal to 1 upon 2 and 1. Now this value you have, this value you find out 1 upon 125, sorry, 1.125. That is approximately equal to 0.9. So we are getting the same answer by different methods. This part you don't have to do in the exam. Remember the direct formula, W and G equal to A and G upon A and W, and then that reciprocal form of it also. Going to the next numerical, it is again application type numerical, and then we will start with total internal reflection, one of the most important phenomena related to refraction. Problem number 3 I am writing. If refractive indices of glass and water with respect to air are 3 by 2 and 4 by 3 respectively, and speed of light in air is 3 into 10 raised to 8 meter per second, find difference in speed of light, speeds of light in water and glass. It can be a 3-mark question, 3-mark numerical of application type. Actually, this is one numerical which makes it evident whether you have followed the concepts of refraction or not. It is not difficult, it is tricky. See, whatever data, what is given, again the same things. I am using the same numbers because you should get acquainted with all these numbers regularly. Refractive index of glass with respect to air 3 by 2. Refractive index of water with respect to air 4 by 3. Speed of light in air is 3 into 10 raised to 8 meter per second. This is given. What is to be found out? Read the last part. Find difference in the speeds of light in water and glass. Now use your common sense. In which medium light will travel faster, in water or in glass? Water is rarer than glass, or observe the refractive indices. This comes out to be 1.5, this comes out to be 1.33. So water has less refractive index, means light will travel faster in water. When you are supposed to find the difference in the speeds, you will have to find out VW minus VG. If you write opposite VG minus VW, your answer is going to be negative. And all of you know, you have studied the quantitative speed. Speed can never be negative, it is always positive. Even if you get the final answer to be negative, maybe you will get few marks, but it will be evident that your concepts of physics are not really clear. Speed has to come as positive. Now how to find this? I will have to generate the formula. Observe the weightage of the question, it is 3 marks. So first you have to generate the formula and then you have to substitute. It is not like the previous one. In the previous numerical, I told you, remember that formula, refractive index of glass with respect to water equal to refractive index of glass upon refractive index of water. Here you have to generate the formula first and then substitute the values. So I am using this data. What is refractive index of glass? VA upon VG. What I want to find out, check VW minus VG, means I want VG, shift this VG on the left hand side, therefore VG equal to VA upon ANG. This is my equation number 1. Do the same treatment to ANW, that is refractive index of water with respect to air, VW. The way I found out VG, I want to find out VW. Shift this VW on the left hand side, VA upon ANW. This is my equation number 2. Now observe what you are supposed to find out, VW minus VG. How you can generate the formula for VW minus VG? Subtract equation 1 from 2. Means what do you do? You subtract the left hand side from left hand side. So on the left hand side I get VW minus VG equal to. Do the same process on the right hand side. So it will be VA upon VW minus VA upon VG. What appears to be common in both the terms on the right hand side? VA into bracket 1 upon VW minus 1 upon VG. This gives me the formula for difference in the speed of light in water and glass. Next thing, substituting values. I will call it equation number 3 for understanding purpose and give heading here calculations. Values of VA, ANG and ANW in equation 3. I am going to put these values, 3 values in equation number 3. Therefore, I get VW minus VG that is speed of light in water minus speed of light in glass equal to 3 into 10 raised to 8. This is value of VA into bracket 1 upon what is VW? 4 by 3. What is VG? Now it is simple calculation because you have generated the formula, you have substituted the values. Now we can manipulate the bracket first. 3 into 10 raised to 8 as it is. This 3 goes up. This 2 goes up. Take the LCM. 3 3s are 9, minus 4 2s are 8, upon 4 into 3, 12. That is 3 into 10 raised to 8 into 9 minus 8 is 1 upon 12. We can cancel out this. 3 1s are 3, 3 4s are 12. 1 by 4 into 10 raised to 8. Write the proper unit here. You are representing difference in the speed, therefore it has to be meter per second. So this is the way this numerical can be solved. I am repeating once again as you can say revision part of it, because one of the important numericals from exam point of view. Write the data given, write what you want to find out, start using the formula for refractive index of glass, generate the formula for refractive index, speed of light in glass, similarly speed of light in water, subtract the first equation from second so that you get VW minus VG, which is desired quantity which is required. Then substitute the values and carry out the calculations. So this is the way these numericals can be approached. Now I am going to move to one of the most important topics in refraction. See, there are certain physical phenomena which occur in nature, as well as we use some of the phenomena for our benefit. I will give you an example. Nowadays the communication is very fast. Which is the physical quantity or which is the entity that travels fastest? We know that light travels with maximum speed. All other entities like sound, heat, etc., they travel little bit slower. So if you want to communicate fastest, what you will have to do? You will have to send the information from one place to the other in the form of light. Then it will travel at a speed of 3 into 10 raised to 8 meter per second, and the information will be transferred from one place to the other even in nanoseconds. So there is one device which is called as optical fiber. It's a very thin fiber through which information, any information for that matter, is sent in the form of light. The basic principle of operation of optical fiber is total internal reflection. We are going towards that topic. Total internal reflection. One part from refraction is remaining, but I am keeping it as it is so that we can study all the natural phenomena which occur due to refraction or its application. Total internal reflection. What does the word mean? Total means complete. Internal means within, and reflection means turning back of light. Although it is termed as reflection, it occurs as refraction. It is called as reflection because laws of reflection are obeyed in that. So I was telling you about optical fiber is one of the devices which uses total internal reflection as its principle. Second application I can tell you, the binoculars. In the binoculars we use prism. Prism we are going to study at the time of dispersion. So binoculars also sometimes use total internal reflection. The periscope, you must have seen a submarine which is watching out something above the surface of water. If the submarine is below the surface of water, the things above can't be seen. So, in order to see above the sea level, there is one Z kind of tube, Z-shaped tube, which emerges out of water, and even if you are within the submarine, you can observe the things above. All these optical instruments use total internal reflection. Always remember, total internal reflection occurs under two conditions only. I will write here in short conditions for total internal reflection. Remember this word TIR stands for total internal reflection. So we are going to deal with that. The first condition is incident ray must be in the denser medium. Means this phenomenon cannot occur if you are keeping the source of light in the rarer medium. You have to keep the source of light in the denser medium, and then only total internal reflection will occur. Second condition is angle of incidence must be greater than critical angle. I am writing notation for that, I subscript C. Now what is this critical angle? We will try and study with the help of a diagram. If these conditions are not obeyed, then total internal reflection will not occur. So I am assuming this is the boundary between rarer and denser medium. In order to fulfill the first condition, let us assume this is the normal. You are making light incident in the denser medium at an angle I, which is less than critical angle. This angle for a given pair of media, critical angle is also constant. It depends upon the pair of media, it depends upon the temperature, it depends upon these quantities. If the angle of incidence is less than the critical angle, we have studied this, if light enters from denser to rarer medium, then the ray of light bends away from the normal. Now you can make out the angle of refraction is less than 90 degree or it is acute. This is the normal case. What new thing is there in this? Nothing. We have studied this at the beginning of chapter refraction. There we said if ray of light is made incident in the denser medium which enters into the rarer medium, it bends away from the normal. Now if I increase angle of incidence, what you expect to happen to angle of refraction? See, I'll write ratios here. I'll write angle for understanding. Angle is say 0, 30, 45, 60 and 90. These are angles in degree. What is sine ratio of the angle? I'll write angle theta. What is sine theta? Sine 0 is 0. Sine 30 is half, means 0.5. Sine 45 is 1 upon root 2, that is 0.7071. Sine 60 is root 3 by 2, that is 0.8660, and sine 90 is 1. If the angle is increased, the sine ratio also increases. Now, if I increase this angle, what has to happen to angle R? It should also increase, because 1 and 2 is sin I upon sin R. By Snell's law, this is constant. If you are increasing angle I, in order to keep this constant, R also has to increase. In the next diagram, I am writing here diagram A. With reference to diagram A, we will discuss again. In diagram A, what is shown is a ray of light is made in the denser medium with angle of incidence less than critical angle. The ray enters the rarer medium and the refracted ray is bent away from the normal. Still, angle of refraction is less than 90 degree. Refer to diagram B. I increase the angle of incidence. I am labeling it as now I equal to IC. If I increase angle of incidence, this is also going to increase. For a particular value of angle of incidence, the refracted ray travels along the surface of the media, between the two media. What is angle of refraction here? It is 90 degree. So, in diagram B, when angle of incidence has a particular value denoted by letter I subscript C, angle of refraction becomes 90 degree. This angle is called as critical angle. What will be the definition of critical angle? Critical angle will be defined as the angle of incidence in the denser medium for which angle of refraction is 90 degree. Suppose I increase the angle further as shown in diagram C, labeling this as I greater than IC. See, initially ray was entering the rarer medium, now it is travelling along the surface. For angle of incidence greater than critical angle, this refracted ray comes back into the denser medium. This is as good as refraction. Here what is the condition? Angle R greater than 90 degree or obtuse. Here, if I term this angle as I, this angle is also I. What does law of reflection say? Angle of incidence equal to angle of reflection. Although this phenomenon is taking place because of refraction, the laws of reflection are followed. Therefore, it is called as total internal reflection. If you keep a source of light here, you will not be able to see this source of light from this side. If this is the case, from here person is watching, he can see the source of light. Here also you can see a little bit of light coming out. But when total internal reflection takes place, no light enters into the rarer medium. intensity of light is reflected back into the same medium, therefore it is called as total internal reflection. So, I'll revise this once again next time, because we have to deal with some definitions, and unless we really understand the concept of total internal reflection, it is difficult to understand working of optical fiber or how mirage is formed, etc. So, we will continue with the revision of total internal reflection and then move further to the other part. Thank you.